Welcome everyone. In this video lecture, we will solve a GET 2025 EC question in which we have to find the time duration calculation when the diode is in forward bias. So the question is, the diode in the circuit shown below is ideal. There is a ideal diode based circuitry is there. So this one is the circuit. Okay. The input voltage given is V1 equals to 10 sine 100 pi t, where t is in seconds. The time duration in millisecond for which the diode is in forward bias during one period of the input is how much. So what is the time duration when the diode is in the forward bias, that we have to find. So in the question it is very clearly mentioned, the given thing is our V1, that is our input voltage. This voltage V1 equals to 10 sine 100 pi t. Okay, so the corresponding graph, I have already made a sinusoidal waveform with the peak amplitude 10 and minus 10. Okay, and this one is V1 and this one is say t. Okay, so this value is nothing but simply we can sometimes we can write V1 equals to a sine omega t. Okay, where amplitude, here the amplitude we can say the amplitude of the input signal is 10, and the angular frequency or omega t simply we can write 100 pi t. Okay, so through this one you can find the time period as well as the frequency. Okay, so omega t, so this t and t will be cancel out, and we can write omega it will be simply 2 pi f equals to 100 pi. Okay, then again 100 pi will be cancel out. Then the frequency of the input signal we can write like 100 upon 2, that is our simply 50 hertz. Okay, the frequency of the signal is 50 hertz. So time period we can say time period. Okay, this one is our time period of the signal we can find, it is 1 by f, or simply we can write 1 by 50. Okay, so one more line that I want to write, 1 by 50. Okay, so what we can write, we just multiply with 1000 and 1000 in the numerator and denominator, so it should be simply 20, and this should be 20 into 10 to the power minus 3. So the time period will be our 20 millisecond. Okay, so is it clear? It is necessary to find this one because what should be the frequency of the signal. So the given one is our sine omega t. Okay, we have written like this, a the amplitude and omega. Okay, so a and omega we have written. Okay, then 2 pi f, then frequency component we have calculated, then time period. Okay, 1 by f. Okay, so the final time period is 20 millisecond. Okay, so it means the signal having this point, this total distance will be, total time period will be 20 millisecond. So one can simply write this point is nothing but simply. Okay, before that I want to just copy this one because, okay, or we can write here 20 millisecond. Okay, this point is 20 millisecond, and this point is our what, simply 10 millisecond, because overall this one is 0 second, 10 millisecond, 20 millisecond time. Say I am saying this one is our time will be at this point, t at point a. I am saying this point is a and this point is b, so t of b is 20 second. Okay, clear this one. So now this one is one thing. Okay, now basically this the circuit is basically a clipper circuit. Okay, no capacitor is there, so this one is a clipper circuit. So first of all we have to find in which interval diode conducts. Okay, so in my very early video in for the clipper circuit I have already made so many problem on clipper, on theory also is given in my videos. So first we have to find out the diode conduction. So for this purpose, as we know, to solve such problem on the clipper, first we have to find the instantaneous voltage. voltage, okay, where the diode is just on. I am saying just on means current current in the circuit, or I am saying the current, okay, the current in the circuit, the current in the circuit, okay, this current in the circuit, current I in the circuit, then the current in the circuit is zero. We have to assume the current in the circuit is zero. Okay, so when it is zero, so if we redraw the circuit, I am just want to give the step by step to how to solve such problem. Okay, so what I am saying, the current is zero. Okay, so current is I value is zero. Okay, I value is 0. Okay, and diode is forward bias. Okay, so diode is, we have assumed that diode is forward bias. Okay, in the very first step we have to just make it forward bias. So and it is ideal, so no voltage drop, just sorted. Okay, then after what we have to do, we have to just apply Kirchhoff's voltage law in this loop. Okay, so one can simply write the Kirchhoff's voltage law. So we can write V1, say this one is your plus and minus. So plus V1, okay, minus I into R. So I already 0. So simply we have to write 0 means, or simply what we are writing IR, okay, minus IR plus 5 equals to 0. Okay, then I, we are saying for the instantaneous voltage, when diode is just on, there will be no current. Okay, so I value is what, 0. So we can say V1 plus the whole term, this whole term will be 0. So V1 equals to minus 5. So this V1 equals to minus 5 will be the deciding factor. How it is deciding factor, that I will show you. So this one is, sometimes you can say, the instantaneous voltage. So minus 5. Okay, so for this purpose, what I'm just, okay, so what we can do, the sinusoidal signal, the input, that is our V1, and this one is the time axis t, and say the sinusoidal input is like this. Okay, wait for a minute. Okay, this one is some sinusoidal signal. Okay, then you have to plot this value is what, 10, this value is minus 10. Okay, and v1 equals to 5. This value is this curve is nothing but simply your what, v1 equals to 10 sine 100 pi t. Okay, this curve, clear, and this point we know, this point also know. Okay, say ta tb. Okay, we have already calculated. Now we have to draw this v1 equals to minus 5 line. So v1 equals to minus 5 line, a line parallel to the x-axis. So can we draw like this? v1 equals to minus 5. This one is the point, transition points. Above this, either diode on or off. So if I am saying, if any voltage v1 greater than equals to minus 5, above this, means what I am saying, above this point, I have already made some theory on this, diode will be what, on, because this value will be greater than minus 5. Diode is like this, yes or no? Diode is like this. Okay, so what happens when this value is greater than minus 5? Okay, diode will be on. So diode will be on. Okay, so v1 equals to greater than minus 5, the diode will be in the on state, or we can say the forward bias. Similarly, the diode will be off below this line when the input is less than minus 5. So here the diode will be off for V1 less than minus 5 volt. Okay, and this one diode on for V1 greater than equals to minus 5. Okay, so this value, what we can write for V1 less than minus 5, below this point, below this input. So below this input, for the this range, this will be the what? Reverse bias. Diode of, is it okay or no? And it is in the reverse biased. Is it okay? Now see, suppose we have to find this point. Now there is some intersection point. Okay. So now I am saying this point is T1 and T2. So can we find this T1, T2 point? If we find this T1, T2 point, we can say during that time from this T1 to T2, the diode will be in the off, because below this one, for the below this input, the diode is reverse bias, the RB, reverse bias, and above this point, this side, the diode, okay, I am just taking different color. Above this point, above this input, okay, diode will be on, diode on. Is it okay or no? Okay. So if we find T1, T2 distance, then we can find the this time interval. So then if we subtract from the period of the signal, then we will get the time during the diode is in the on state or forward bias. So for this purpose, simply now the curve as we know, and minus V1 equals to minus 5, then we can find point, this point, and this point we can easily find. So how we will find this point? For this purpose, what we will do, we know the graph of the sinusoidal, so we can write as 10 sine 100 pi t is nothing but simply minus 5. This one is also V1, and this one is also V1. I am saying V1 equals to 5 minus 5, and this one is this 10 sine 100 pi. Then if we solve this one, okay, okay, I'm erasing it, otherwise there will be confusion. Okay, means this signal and minus 5, so both are intersecting at 2 points. So we will find from this by solving this one. Okay, so how we will solve? Simply 10 sine 100 pi t equals to minus 5. So what we will write? Sine 100 pi t equals to minus 5 by 10 we can write, or minus 1 by 2. Is it okay? Very simple. Clear? Now what we will do? Now see, 100 pi t equals to sine inverse minus 1 by 2. Okay, so that value we have to find. Okay, so now I'm saying, now I'm focusing on this point, sine inverse minus 2. How to find the value? Okay, for this purpose, it is very simple. Okay, suppose if you know the sine graph, okay, so one value is minus 1 by 2. Minus 1 by 2 will be like this, minus 1 by 2 in the middle, okay, or to make it in the middle. Okay, means this one is 1, so any minus 1 by 2 line. Okay, so now this point we have to find what is the point. Okay, so this point will be pi plus pi by 6. This point will be simply pi plus pi by 6, and this point is 2 pi. So 2 pi minus pi by 6. Is it okay or no? Or directly you can use the calculator. So it should be 7 pi by 6 and 11 pi by 6. Is it okay or no? Pi plus pi by 6. Okay, sine 1 by 2. 1 by 2 value of sine will be what? 30 degree. Pi by 6. So but it is negative, so pi plus pi by 6. Okay, so pi plus pi by 6, 7 pi by 6 and 11 pi 6. So this value will be simply either 7 pi by 6 or 11 pi. You can directly use calculator also, but this is the simple one. So that's why I am showing you. Okay, then there is a 2 points. So first case, if you consider 100 pi t equals to 7 pi by 6. Okay, so this pi cancel out, and I am saying this point is our t1 t2. Okay, in the above case we have assumed t1 t2. So t1, so t1 point, one point will be 7 by 600. Okay, 7 by, or 600. Is it okay? Then if we solve this one, okay, it will come around 11.66. Already I have calculated. Okay. Similarly, for other point 100 pi T2 I am writing, and we are writing 11 pi by 6. 11 pi by 6. So pi pi will be cancelled out. So T2 will be 11 by 600. So if we solve this 11 pi by 600, it will come 18.33 millisecond. Okay. So this one is the important result. We can say T1 value, T2 value. Okay. Now from the graph that we can say the T1, T2 value is already calculated. T1 is how much? T1 is 11.66. This value we have calculated. Okay. This value we have calculated. We have calculated this value 11.66, and this value is 13 point, sorry, 18.33 millisecond. Okay, and this one is also in the millisecond. Okay, now T1, T2 is known to us. So if we find the value T1, T2 is known to us. Okay, so this distance we can find. Okay, this distance we can find. Clear? So if we find T2 minus T1, T2 minus T1, this T2 minus T1 will be the time where the diode is off. So that's why we are writing T off. Okay, T2 minus T1 is our T off time. Okay, where the diode off, where the diode off time. Okay, diode off time. Okay, so T2 minus T1 is clear. So this value simply we can write as T off equals to T2 minus T1. Once again I am writing 18.33 minus 11.66. Okay, so now it should be how much? If we subtract, it is come 6.66 millisecond, all in milliseconds. So it should be t of time will be 6.66. So now we have to find the time when the diode is on during the first time period. So the time period, this point to this point is our 20 millisecond. We have already calculated 20 millisecond time. Okay, so the T on, or when the diode when diode on, or forward bias, or we can say the forward bias. So that is nothing but simply the time period, the T minus T off. So time period is how much? 20 millisecond, and T off is our 16.6, oh sorry, 6.66 millisecond. So if we subtract, it will come 13.33 millisecond. Okay, so this one is the means solution, final solution. So the answer will be what? How much? 13 point. I'm writing the green color. 13.33 millisecond. It is in the millisecond, so no need to write millisecond. So, but okay, in exam you have to write 13.33. Okay, so this is the way to solve. Means if someone asks what should be the waveform for that particular circuit. Okay, output waveform is not asked in this question. So but if someone asks the output waveform, so you can also solve the output waveform for. Suppose this one is the circuit, we have to find the output waveform, plus minus V naught. Okay, so how we will do? It is very simple. Once again, the we have to first draw the graph for the sinusoidal signal. Okay, like this, it is varying like this. Okay, for first half. Okay, this point is our 10, and this point is our minus 10. Then after we have to draw a line. Okay, like this, that is our V1 equals to what? Minus 5. Okay, transition line. Above this, diode on, we have calculated diode will be on above this point, and diode will be off below this. So when diode is on, okay, when diode is on, this is sorted. Okay, then after you have to apply Kirchhoff's voltage law. So diode on, so what would be the output value? V naught. By applying V naught, plus 5 equals to 0. So V naught equals to minus 5 when diode is on. When diode on. So output value will be minus 5. And when diode off, diode off, okay, the circuit will be like this, okay. So V naught is nothing but simply V1, okay, when diode off, yes or no? So what we can say? So we can say during diode on, the input is like this, output is like this, V1 equals to minus 5, okay. So for this part, okay, and when diode is off, it follows the input, okay. So it is like this, okay. The green color, okay. The green one is the output waveform. In the question, it is not asking the, but we can say, okay. And if you are interested in this point only, so you have to make like up to this, okay. Clear? So this is the means output waveform, okay. It is not asking, but the, this one is the solution. Means in question, they are asking about the t on, okay. That is our t minus t off that we have find. So this is all about this question. We have we have to go through like that processes to just how to simplify the questions like that, okay. So this is the step. So simple question. So we can say the what we can say the answer for the signal means time duration will be 13.33 millisecond. So this is the question of GATE 2025 EC. So thank you for watching this video. Thank you.